Hi, welcome to my lecture on mechanical design for our process equipment design class. Our lecture will be as follows. First, I'll cover review and then intro to mechanical design. The review is on the milestone 1, heat exchanger design calculation, milestone 2, simulation of heat exchanger design, and milestone 3, a little bit on PI90. And this is to give you guys a picture of how everything came together. Okay, right. Oh, this is basically the big picture whereby your MS1 covers chapter 2, chapter 3, and your MS2, which is on simulation of heat exchanger design using HYSYS here, using HYSYS. And then your PNID is actually a small part of flow sheeting, chapter 4. Alright? For your information, mechanical design is chapter 13. For your chapter 13, sorry, in the CNOT volume 6, chemical engineering design principles and practices book. So now you can see the big picture. I want to zoom a little bit and remind you guys that the importance of doing your mass balance, as I've explained many times, and I think you guys are still a bit in need of improvement, a lot of improvement. For your information, you can go back to your CPP as well to understand material balances. But I know you guys don't understand where it's applied. Okay, where are mass balances important? It's important because you will want to understand the process flow of what you're designing to solve the problems. Okay, give you also information on how to select system boundary and design basis. Right, you may ask what this is. If I click on this and you go to chemicalprocessing.com and this page, you'll actually find information on system boundaries and design basis, which is here. Starting from here, the objective is usually what you want to solve, and your design basis are the inputs, which are material balances. What goes into the plant, how much, what's the pressure, what's the temperature, what's the condition, what's the phase. Okay, also the outputs, because yours is only one equipment, so it's not so large, it is not so complicated. But when you are doing your final year design project, plant design project, you will need, the whole team will need to look at the whole plant design. Okay, so this is sort of an introduction to that part. Your system boundaries are your constraints and your boundaries. Your constraints are regulation and so on and so forth. The boundaries are the limits of temperature and pressure on all streams entering and leaving the unit. As you know, your constraint here is your pressure, high pressure gas coming in at atmospheric temperature, and then when you reduce the pressure it goes cold. So that's your constraints, that's your boundaries. Okay, so going back to our presentation. Okay, so system boundary and design basis, clear hopefully. Next, allows you to estimate reactor and process yield. The ability to estimate reactor and process yield is very important because we need to find out if, I mean, this one doesn't apply to your present heat exchanger because it's not a reactor, but you need to understand how much material goes in and comes out of a process to understand if it's economic to do it or not. Right, this part I will cover after I cover the others. I will move next to the fundamental of energy balances and energy utilization. I also found out that, remember I asked Do you guys understand where you apply energy balances? Basically, most of you guys, I think when you state energy balance, you think it was only to get the mass balance. It's actually wrong. You need to state the total energy requirement of your system. Why? Because you need to supply energy. You can't expect your heat exchanger just because you designed it that way, you will have that amount of heat to give to the gas. You have to find that energy from somewhere else. Okay, so this is very important to show.